Okay. So in 1.2 they also talk about absolute value function. We're in pretty good shape on that. We know that absolute value turns numbers into non-negatives. Turns 0 into 0, but anything else becomes a positive. And that's really all that this says. Here's one of the things on AP test that can cause some problems. You're going to get questions that ask you to do multiple things. Let's make certain we answer every question. We're to find the domain and the range of each function. Support your answer with graphing calculator. We're not going to do this on this exercise. We will graph the function, and we will list intercepts, asymptotes. So we got a lot of things to do there. I'm really hoping that we can find the domain pretty quickly. And I always just say, let's start with the value of x and let's look at our order of operations. So if I choose x, a value for x, can I subtract 1 from any number? Yes, I can subtract 1 from any number, but next, can I take the square root of any number? No, therefore x minus 1 must what? Must be greater than or equal to 0. So my domain is x is greater than or equal to 1. Now, if you're seeing 1 on a number line and greater, we're probably going to be utilizing interval notation, as we said yesterday. So we just start walking from negative infinity, and we walk and we walk and we walk to the right, and this thing exists at 1, and it continues to exist until infinity. Those are the same answer, and they're equivalent to this number line. Chances are we're going to be working in interval notation. Now, range is always a little bit trickier. And the range, a lot of times I'll be lazy and I'll just get my graphing calculator and I'll graph the function and just determine what y values are represented by starting from the bottom and working up top. But let's analyze this for a second. Obviously, 1's an interesting value. When I put 1 in here, I get 0, square root of 0, 0, plus 2, 2. If I put anything bigger than 1 in there, I'm going to get a value bigger than 2. Therefore, my range, the y values are at least 2. Is there a limit to how big they can get? Could y get to 1 billion if I wanted it to? Yeah, I just got to put 1 billion billions in here, and the square root of 1 billion billions is 1 billion, and I made it. So it is just as I start at the bottom, if I start at negative infinity down, oh, negative infinity is bad, stop that. Negative infinity is bad until I get to 2, and I can continue up until I get to infinity. Okay. No question here. I'm going to start with my myvox and build around my myvox. Is that okay? I'm going to start at 1. I get 0. Square root of 0, 0, plus 2, 2. Now, I might want to do this. I could just kind of willy-nilly pick values for x. Like I could pick, let's go to 6. We got room. And I get 2 plus the square root of 5. Well, what is the square root of 5? Maybe I'd rather have some good values. The key is I want x minus 1 to be perfect squares. Like 0 or 1 or 2 or 4 or 9. You might want to do that. If x minus 1 is 1, then x needs to be 2. If x minus 1, I don't know why I chose 2 here. If x minus 1 is 4, then 5. If x minus 1 is 9, then x is 10. Those are good values. Choosing x minus 1 to be 2, not such a good value. Okay, so put in 2, square root of 1, 1, plus 2, 3. Put in 5, square root of 4, 2, plus 2, 4. Put in 10, square root of 9, 3, plus 2, 5. So 1 gets me to 2. 2 gets me to 3. 5 gets me to 4. And at 10, I make it up to 5. And I look like this. On and rightward and upward to infinity. Am I right here with a solid dot, or should this be circled? Dot's good. We can be equal to. Okay, so I got my domain, I've got my range, I've got my graph. Intercepts. Do I have any x-intercepts? Nope. Y-intercepts? Nope. Asymptotes. Is x equals 1 an asymptote? Does it keep getting sucked into 1 closer and closer and closer and closer and closer, or does it just slam there and stop? Just slams into 1 and stops, not an asymptote. Coming downward, it just slams into 2 and stops, not an asymptote. So, intercepts, none. Asymptotes, none. Questions there? Okay. Let's go with domain. Can I subtract 2 from any number I want? Sure. Can I divide by any number I want? Can I divide by negatives? Yeah, just can't divide by 0. So x minus 2 cannot be 0. Therefore, our domain, x cannot be 2. And you could list that in interval notation, negative infinity up to 2, or union 2 to infinity. I do suspect this would be the preferable answer. We'll see as we move on. Then range. I want you not to graph. I want you to analyze range. So where do I want to? I probably want to analyze around 2. Follow this. If I put 2.1 in here, I get 2.1 minus 2.1, 1 divided by 0.1, 10. If I put 2.01 in here, I get 1 on 0.01, 100. Pretty clear to see it. 2, if I'm a little bit bigger than 2, I'm going up forever. But x can't be 2. Like 2.000001, I put that in there, I get 1,000,000. Right? So I'm just going to give myself a mark. I'm going up this side. Let's put in 1.9. 1.9, I get negative 0.1. 1 on negative 0.1, negative 10. I'm down here. Is that all right? Okay, so I've analyzed around 2. How about when x gets huge? Let's put 100 in here for x. 1 on 98, virtually 0. Put in 1 billion. 1 on almost 1 billion, virtually 0. When do I hit 0? Not going to get to 0, am I? What about negative numbers? 1 on negative 1 billion. Not going to get to 0, but I'm going to get close to 0, aren't I? I'm getting sucked into 0, therefore we have this asymptote. So I've got x equals 2 is an asymptote. I've got y equals 0 is an asymptote. And I about have enough to graph this thing. I guess I'll just list some of these we talked about. 2.1 gave me 10. At 2.1, I'm almost on the asymptote. Let's just go out to, or let's go to 3. If I go to 3, I get 1 on 1. So this is running pretty tight to the asymptote. I'm going to jump out to 10 since I've got 10 spaces on my graph. At 10, I get 1/8. So at 10, and depending on how much guidance you need, we can certainly get a pretty good representation of this curve. Okay. So let's move to the left. We already talked about 1.9. 1.9 gets me 1 on negative 0.1, negative 10. I guess I'll go to 1. 1 gets me 1 on negative 1, negative 1. And just because I have the room to do it, I'm going to go to negative 10. Negative 10 gets me 1 on negative 12, or negative 1/12. Almost 0. Okay. Have we answered all the questions? I've got domain. Range, never quite talked about range. Well, we did talk about it, I never wrote it down. The range, y cannot be 0. And I could write that similarly in interval notation. How about intercepts? Is there an x-intercept? No. Is there a y-intercept? Just not a good one. There's a y-intercept. Any point on the y-axis, they all have one thing in common. Every point on the y-axis, what do we know? 0, 1, 0, 2, 0, 3, 0, 4. We know that x is 0, right? So when we're looking for y-intercepts, you might as well just say x equals 0. If x is 0, I get y equals 1 on 0 minus 2, negative 2. So 0, negative 1/2 is our only intercept. Just a whole lot of easy. Not one hard thing there, just a lot of easy. All right. Careful here. Can I subtract any number I want from 2? Yes. Can I take the third root of any number I want? Third root of negative 8. Negative 2 times negative 2 times negative 2 equals negative 8. Can I take the third root of any negative number I want? Yeah, third root is 0. 0 times 0 times 0. So x can be any number I want. Can I add any number I want to 1? Yes. Therefore, my domain is all reals. I'll take that abbreviation and I'll let you know if that works at a later time. All real numbers. Might have to write it out. It's kind of like from English paragraph. Stands for paragraph, stands for all reals. Okay, so let's consider y's. I know I can put 2 in here for x. I get 0. I get 1. As x gets bigger and bigger and bigger, this becomes more and more and more negative, which gives me bigger negatives coming out of it, right? Negative 1 billion, I'm going to get a reasonably large negative. I can keep going down forever. As I go to the right, it's going to go down forever, isn't it? You might even want to give yourself a little arrow over here. As I go to the right, it's going to go further down. As I put bigger and bigger and bigger negatives in here, this becomes a bigger and bigger positive. So it's 1 plus, it comes out of there, it's going to go up and up and up. So I know we're doing this eventually. You might want to do that. So my range is all reals. Is that okay? I get it. It's going to flatten out. Third root of 1,000 is only 10, so when I go over 1,000, I'm only going up 10. But I'm going to still be going up. Okay. So let's pick some values. Guess what my first choice is going to be? Fingers. Yeah, 2. Right. 2. I'm going to build around 2. 2 is the most interesting value of x. So put in 2, get 0, third root of 0, 0 plus 1, 1. 2, 1. Put in 3. 2 minus 3, negative 1. Third root of negative 1, oh, I got lucky, is negative 1 plus 1, 0. Now, I want 2 minus x. I want 2 minus x to be perfect cubes. Like, I want 2 minus x to be things like 1. Because I know the cube root of 1. What would x need to be? 1. Put in 1, get 1, cube root of 1, 1, plus 1, 2. And if we didn't know better, we think that's a straight line right now. Well, 1's a perfect cube, but so is 8. I want 2 minus x to be 8. What does x need to be? Negative 6. Negative 6 is a good choice. This is almost like that stamping technique I use. We're not just going to pick values of x, we're going to pick good ones. Put in negative 6, get 8, third root of 8, 2 plus 1, 3. So I'm all the way over at negative 6, 2, 4, 6, before I get up to here. All right, how about negative 8? What does 2 need to be? Or what does x need to be? 2 minus what to get negative 8? 10. Put in 10, get negative 8, third root of negative 8, negative 2, plus 1, negative 1. 10, I'm at negative 1. Okay, I got really lucky to get, so we have no asymptotes. We got really lucky right here to get our x-intercept. Our x-intercept is 3, or 3, 0. But there's a y-intercept as well. But what do we know about every point that's a y-intercept? X equals 0. So if x equals 0, I get y equals 1 plus third root of 2 minus 0, or I get the ordered pair y-intercept of 0, 1 plus third root of 2. It's the exact value. Okay. All right, if you're looking at this on the video, this would probably be a good place to pause the video and just try this problem on your own. Okay, let's take a look at domain. Can I square any number I want? Yep, can I divide any number I want by 1? Or from 1? Can I take 1 divided by any number I want? No, I can't divide by 0. X squared cannot be 0. X cannot be 0. That's our domain. So let's consider values close to 0. If I put 0.1 in here for x, I get 0.01. 1 divided by 0.01 is 100. If I put 0.1 in here, I get 2 minus 100. Pretty big negative number. If I put negative 0.1 in here, the negative gets absorbed. I get 0.01 down here. 1 divided by 0.01, 100. 2 minus 100. See what's happening as I get close to 0 for x? As I get close to 0 for x, we're getting big negatives in both directions. From both directions. Now, before we just start picking values and graphing, let's think about what happens. We found out what happens to x near the asymptote. What happens is we get far away from the asymptote. For instance, if I put 10 in here, I get 1 on 100. I get 2 minus 1/100th, almost 2. If I put a million down here, I get 1 on a million millions. 2 minus 1 divided by a million millions is virtually 2. Will it ever get to 2? Nope. It won't get to 2, but it's going to get really close. I also note if I put positives and negatives in here, I get the same thing. Therefore, say it. This graph is, if I get the same thing to the right as I get to the left, this is a what graph? Even. It's an even function, right? Everything. So I really have to build 1/2 of it and mirror it. Okay, so I'm going to put in, I think I'll go ahead and put in 0.1. I put in 0.1, I get 0.1 squared, 0.01, I get 100, geez, I get negative 98. Well, that's not very useful to me, but I know that it goes down very quickly. All right, so I'm going to put in 1. I get 2 minus 1 on 1, I get 2 minus 1, I get 1, but that's what I get if I go to the right or the left. And if I want to put in, say, 10, I get 2 minus 1 on 100. So I get 1 and 99/100ths. But I get that if I go right or left. Bottomless pit, volcano graph. Deal with those quite a bit. Do I have a y-intercept on this graph? No. Do I have x-intercepts? Good. But every x-intercept has what in common? For the x-intercept, this is an x-intercept, x-intercept, x-intercept. They all have y equals 0. Right? Put 0 in for y. Solve for x. I'm going to square both sides. or excuse me, multiply both sides by x squared, I get 0 is 2x squared minus 1. I'm going to add 1, divide 2, take the plus or minus square root of, and I find out that my intercept occurs when x equals plus or minus root 2 on 2 when we rationalize. So root 2 on 2 plus or minus root 2 on 2, 0 are the x-intercepts. Questions there? Okay, determine whether the function is even, odd, or neither. Here's the good news on this. Even and odd functions, it's the same test. They'll tell us what the graph does to the right. They'll tell us f of x equals. We want to see how what f of x does to the left. Is it the same? Is it the opposite? Is it neither the same nor opposite? So the test is the same. I want to put negative x in here. When I put negative x in, and I take the negative x, think of it in parentheses, to the third, what happens to the negative? Does it survive or does it get absorbed? Survives. Therefore, I would have y equals negative x cubed, or the opposite of x cubed. So since x cubed times negative 1 gives me negative x cubed, these are opposites. So the height to the left is the opposite of the height to the right. Therefore, this is odd. Oh, we just have to pay attention to the exponents. Well, be careful with that. That will fail you. When I put negative x in, think of this as f of x equals. So f of negative x is the opposite of x plus 2. Are these the same? X plus 2 isn't negative x plus 2, so the height to the right is not the same as the height to the left. It's not even. Are these opposites? They would be opposites if x plus 2 times negative 1 was equal to this. But it's not. So this is a neither. C. Do we know what the graph of that looks like? Looks just like a parabola except what? Down 3, right 3, left 3, up 3? Down 3. Looks just like one. This is post function. So it's a parabola, but it's down 3. Is that even, odd, neither? It's even. Or if I put negative x in and square it, I get positive x squared minus 3. Even. The negative gets absorbed. Okay? D. Likewise, if I put negative x in here and square it, the function stays the same. So my height to the left is the same as my height to the right. Even. E. If I put negative x in, if I call this f of x, then f of negative x is negative x. The negative gets absorbed, x squared minus 1. Are these the same? No. Are they opposites? This gets people. Let me ask you. Are those opposites? 7 and negative 7? Yeah, 7 is clearly the opposite of negative 7, right? These aren't opposites. Because when I multiply 7 on 1 by negative 1, I'm either going to take 7 on 1 times negative 7 on positive 1, or I'm going to take 7 on 1 times positive 1 on negative 1. How about these? Are these opposites? Yeah, because if I multiply this by negative 1 on 1, I get the same thing. These are opposites. So the height to the right is the opposite of the height to the left. Odd. Okay. Okay, let's take a look at example 3. Test each equation to find what symmetry its graph has, then draw a complete graph of the equation. Let's just come up with some solutions to this. Just based on inspection. What ordered pairs can I put in? Something squared times something squared equals 1. Give me an ordered pair.
Yeah. 1, 1.
1, 1. Good. Now, does it make any difference if I choose 1 or negative 1 for x? Does it make any difference if I choose 1 or negative 1 for y? All of these are points on the graph. Not the only points, but they're all points on the graph. Which right now, if those were the only points, I'd say, well, it's symmetric across the y-axis, symmetric across the x-axis, and symmetric about the origin. All right, how about this? How about if we get tougher ones? If x is 2, I get 4, divide 4, I get y squared equals 1/4. Therefore, y equals plus or minus square root of 1/4 or plus or minus 1/2, right? But x can be plus or minus as well. So I get 2/2, I get 2 negative 1/2, I get negative 2/2, negative 2, negative 1/2, and we think, ooh, that's an ellipse. Well, how about this? Plus or minus 1/2 for x and plus or minus 2 for y. 1/2 and up 2. Now it's got more of a shape like this. It looks like we have an asymptotal behavior. Tell me why the y-axis is an asymptotal behavior. Every point on the y-axis has one thing in common. X is 0. Could x be 0? If I have 0 times y squared equals 1? It can't be. So I do believe this graph looks like this. X and y cannot be 0. But we definitely have, we're looking for symmetries. So our symmetries, we definitely have, appear to have x-axis, y-axis, and rotational symmetry. Can anyone tell me what the graph of B is? Not so sure. Does it sort of seem to follow along with A at least? Whatever value goes with x and y, the positive and the negative work too. See what I'm saying? If I use 3 for x, and negative 3 is the same, and if 3 happens to pair with 4 for y, negative 4 is the same, I've got the same situation going on we had back here. This is going to have all rotational symmetries. Do we know what that graph is, though? Anybody? How about if I divide both sides by 36? I get x squared on 36 plus y squared on 9 equals 1. It's an ellipse, and it's ellipse centered at 0, 0. In an x direction, we go 6. In a y direction, we go 3. I believe it's that ellipse. So once again, we have all types of symmetry. Okay, so we will continue in section 2 tomorrow. You won't quiz 2 tomorrow, but 1 is possibility of a quiz tomorrow.